Hi there. So I've been trying to educate myself a little bit on this crazy vibe coding that I'm hearing so much about because I've been programming for I don't know 30, 40 years or something now, and it's all quite new to me, quite difficult, quite scary. So the best thing to do is to educate myself on these new tools and see what they can do for me. So we've got a project, INST, which is all about locating casualties in mass casualty incidents and also is applicable to other kinds of mass gatherings like festivals and concerts and that kind of thing. We've been working on it for quite some years, and we've got some technology which we're now testing to work out the position of people via wearables. And I need some development tools to be able to work out what's going on and to test out what we're doing. And essentially, cutting it very far down, we've got these tags. If they've got a line of sight to a satellite system, then they'll give you an absolute GPS coordinate with a level of confidence. And if they haven't, they'll use another technology, ultra wideband, to give relative position. So, for example, indoors. And we're linking that together. We've got some clever maths going on, and I need to begin to start looking at how that all hooks up and how it works and doing some testing. So that's the plan. Now, the thing is, to do that, I need something that will run on, laptops and mobile devices like pads when we're out in the field doing this work. I'm not a web developer. I don't develop in JavaScript and Node.js or anything like that. I got a vague idea, but I don't do it. I don't know about it. So what am I to do? Well, I thought this might be a really good use case to try vibe coding because it's fairly complicated, but it's a constrained project. It's for development purposes. And if I could get this going, it would enable me to do something that otherwise I couldn't do without either me spending months and possibly longer of my time understanding web development or paying somebody, contracting somebody in to do that who has that skill set. So I thought, well, give it a go. For no particularly good reason, I started off with Anthropic's Claude.ai, and I started off with the chat feature of that, which is where you sort of talk to it and it gives you responses and amazingly powerful. There's good and there's bad. The stuff it comes up with is astonishing. Equally, it can make crazy mad mistakes and break everything, which can be very frustrating. And I'm really starting to understand the huge, huge importance of prompt engineering. And I view the future being kind of an evolution of my career in the sense that, I started off with data sheets and bits of paper and books being mailed to me. And then Google came around. For younger people, no, Google hasn't always been there. And I would suggest that I became quite good at constructing Google queries to get the information I need and evaluating the quality of the responses and working out what to do with the responses from those queries. And I kind of view this vibe coding stuff as that process on steroids, and it's all about how do you construct the prompt and constrain it, and how do you evaluate what you get back, and how do you iterate on that? And I think that's a big problem as well, because iterating can be a problem. It can be a problem, at least for me, to get back where you came from. So there's a whole new set of, I think, engineering development techniques that we need to learn here. And it's quite exciting for me because it's early days, it's new stuff. So with that said, I moved on from, the chat interactions were quite limiting after a while because, at least with Claude, as far as I know, it generates these artifacts as an output of what you're asking it to do. And you then have to download them individually and copy them across, and the names have to be changed. And it's a slow, arduous process. The actual generation process is slow as well. Obviously, it's very, very good. It's a huge productivity boost, but it's frustrating. It reminds me of the bad old days when we had very slow computers and we'd go off for a cup of coffee for half an hour to wait for it to do a job. So then I discovered this other tool. I'm no expert. I'm not recommending particular tools or platforms. It's just my journey. So I found Chat LLM, which is a token-based system that front ends a number of different AI engines like ChatGPT, Claude, Sonnet, others. I still have a lot to learn about the differences between these. But I like Chat LLM because they've got a downloadable coding tool which looks to be based on Eclipse, which is what you can see here. And for those who know, excuse me, not Eclipse, not at all Eclipse. Oh, I'm thinking about Eclipse. It's based on VS Code. And what you can see here is you've got a usual sort of VS Code setup with your files on the left-hand side, stuff that you're working on, some informational terminals and things down at the bottom. On the right-hand side is this kind of code chat window where I'm chatting away. In this case, you can see at the bottom down to Claude's Sonnet 4 and asking it to do things. And it automatically references the files that I've opened. And I mean, I shouldn't really complain, should I? Because this is like magic, but it's a frustration that I can only open 6 files at a time, no doubt because of the limitations of where we are with GenAI. But it's amazing, really. So I'm sort of saying, okay, I want you to do this, and this doesn't work, and I'd like you to try that. And then I like what you've done here, so you can see, give me a git commit message with all your changes, so I can commit this code, so I can iterate, and I know where I stand. And I'm developing my own workflow as I begin to understand how to drive these tools. And really, a lot of what's been very surprising about this journey is that you don't think it's going to be able to do the things that you might ask it to do. So you don't, or at least I don't. I'm of that generation. And I have to kind of force myself to say, I know it won't be able to do this, but I'm going to ask it anyway. And then it blows me away because it can do this stuff. It's just, that's a key hurdle, actually believing you should ask the question. Absolutely amazing. So yeah, so I don't do web coding. I couldn't have done what I've been doing here, but I've been working now on and off for a week or two on this positioning application, which I've called INST Visualiser. And this is the code that you have here. It's really comprehensive. It throws all sorts of stuff in. After I'd begun to get going with this, I started talking to Claude about how we re-architect separation of concerns. It's been telling me we can break down these overly large files into these different files, different versions of application support, mapping support, visualization support, communication support. Amazing. So to show you what we've got, if I switch over to this repo, this is a public repo in the DD org. And again, all of the files, which do need a bit of updating, were generated by Claude. So this readme.txt, all of this about the project, about what we're doing, the technologies, how you use it, the data formats, all in there, and to be honest, it can be tweaked. I could spend time on tweaking this and improving it, but just the fact that we have this as a developer, we don't like documenting. So this is a massive boon for me and for others if I get this right. I do think there's a problem that it has a tendency to kind of throw in a load of things on the off chance that they're helpful. And as an engineer, I can find that obfuscates the things I need to know. So I think one of my jobs is to see that and to prompt engineer so that things like the documentation that Claude generates for me or other GenAI engine is fit for purpose. I think a lot of people perhaps aren't doing that. I think we need to learn some lessons here. For example, these hardware integration examples are probably entirely irrelevant to what we're doing. So a bunch of stuff in here. Then it knows all about GitHub and workflows and so forth. So I've got a basic deployment workflow that deploys this web app onto GitHub pages. I'm in the middle of creating some testing and deployment workflows, which are going to be a lot more complicated. They're not working yet. But again, Claude has done all this for me. It's generating the YAML to do the testing. It is quite incredible. It's I think, what is the term? Force multiplier. So then if we go back to the INST Visualiser, to the live demo, here we go. So this is where we are at the minute. Quite excited about this. there's loads of stuff in here that it's added. Some stuff I didn't even consider. I would never code in at this stage of application development because it would be far too time consuming for me to do it, even if I could, even if I knew how to drive the language tools. And it's thrown in a load of things which I'll show you. And I've basically been prompt engineering. I've been finessing what it's coming up with. And as I say, it's great, but it can be frustrating because everything works. And then you say, well, I want to make a change here. And loads of non-related things break. Like I've been changing some of the physics engine and the buttons stop working, these kinds of things. Now, I'm sort of coming to the understanding that this is about constraints. So I need to say things like, okay, I want you to change the physics engine to do X, Y, Z. Make sure you localize your changes and don't go and fiddle about with the UX and the buttons because you keep breaking those things. And that seems to generally be pretty positive. That seems to work. So what have we got to? Well, we've got an initial sort of desktop layout. The the aim of the game is that this will reformat to display on tablets and phones. I've been around those loops, and again, because changing one thing, it's a bit like whack-a-mole, changing one thing breaks other things. I've stepped back from that. So I'm getting functionality in at the desktop, and then we'll get into breaking out alternate UX layouts for other kinds of form factors. And up at the main, well, the fun is happening here. The system controls, some statistics on the number of nodes we've got, connections between them, messages received, and the accuracy we've got. It's calculating. All of this is live. It's using a protocol called MQTT, which you're, if it embedded, you will know about. So this is actually connecting out to an MQTT server of your choice, and we can push messages via publication into that server in this particular format, which is detailed in the README. And it will start working with those and visualizing those. Now, because that's fiddly, that involves me having lots of bits of hardware and running around, which is not that easy. Claude came up with a simulator for me. Wow, how fantastic. So I can connect up to my MQTT server there, which I've just done. You've seen we've gone connected. That worked. And before we move on, what I'll show you is there's a log at the bottom here, which tells me what's going on. Claude is very helpfully adding in a load of logging, and I can have more or less. Very, very helpful stuff. And, for a non-web developer like me, I'm sort of getting into all these developer tools that we've got over here. And I got a shed load of logging going on, which Claude changes around as we run into problems together. And it wants me to put logging in to figure out where the problem is. And then I tell it what the logging errors are. And it says, oh, yes, I can see where that problem is. Real good stuff. So it's got loads of this stuff in with funky icons. I'm connected up. I'll go into simulation mode. So I'm going to now update fairly frequently every second. The simulator, because I've constrained it to do this, is publishing messages itself separately into the MQTT server. And those are coming via subscription into the visualization engine. So this is kind of like a real thing, as it were. So if I start that simulation, you can now see that I've got a set of example nodes, which we're receiving the data over MQTT. And I've done a lot of experimenting with the physics engines of how to lay these things out, because a lot of this, particularly for indoor positioning, is relative. And we need a way of sort of calculating how far nodes are from other nodes based on knowing distances between nodes. Now, this is not stuff I do. Again, I'm not a mathematician or computer scientist type. I'm merely an engineer. So I chatted for a long time with Claude about the way to do this, and I had many failed experiments, and we came up with a kind of mass and spring system. So basically, those distances are links between the nodes, which are sort of pulling them together, and there's a repulsion between the nodes, pushing them apart. And the idea is probably needs a bit more work, but again, it's for development, not production. We'll be using a different set of algorithms for production, which is one of my colleagues within their scope. But this hopefully gives me a bit of an idea, which is all I need. So you've essentially got different kinds of nodes here. You've got a gateway node in the red there, say gateway. Each of these has a unique ID, which is coming out of the hardware. And then we've got some, what I'm calling the R nodes are sort of anchor nodes, and the T nodes are sort of tag nodes. They might be a wearable. And there's a little bit of jitter it's injecting into it. And you can see the data comes in and it's updating the display. And so this was the first point I got to. I was really happy with what we've done here. And thinking ahead a little bit towards the mobile platform, I've got the ability here to sort of maximize out the view. And when I do, it recenters and it tries to keep everything on screen and so on and so forth. Really, really happy with that. Now, that was sort of phase one, as it were. Now, what I really need to get to for this testing to be useful is to link these node positions to the real world, to being on top of a map. And that's, you do that with your phone, don't you? You can go onto the map on your phone, you see where you are. So in that sense, it's a solved problem. But it's actually quite hard to do, and it's particularly hard to do when you're indoors and you're trying to figure out where you are without line of sight to any satellite systems. Different techniques. There's Bluetooth beacons, ultra wideband is coming along. That's used in Apple AirTags. We've got ideas of Wi-Fi signal strengths. There's lots of stuff we can do here. We quite like ultra wideband. We think that's a really good way of doing things. So we're looking at that in a minute. And what I then did was I vibed with Claude, and we've gone off and we've been trying to work out how to add another kind of view, which is the map view, which is what I'm going to show you now. So let's switch over to the map view. And here you go. Everything immediately sort of constrains down because we're now looking at sort of real world coordinates, and these test nodes are quite near to each other. As you can see, it's quite busy, so maybe I need to have a bit of a look at that. But what we're seeing here in map mode is that the system is pulling down a set of tiles from a range of different tiling servers. They have a maximum resolution. So what we'll do is we'll turn off automatically zooming, and we'll step out a little bit. You can see I've got a kind of a zoomed in satellite image there. Zoom out a little bit further, and you can see that I made it this location. This is somewhere in Liverpool. I'm going to switch over to OpenStreetMap, and maybe I need to zoom out a little bit further. There you go. So I've got an OpenStreetMap map set up for these tags, and I've got a few different ones for me to play with. I've got topographic. I've got some imagery there. Really cool stuff. I can do more work on the zooming. I can get that into a higher resolution, but it's good enough for what I need for now. So if I just kind of rezoom all that in again, decided it was quite busy having all of these tag distances all over the place, particularly when we're sort of zoomed in. So I said to Claude, hey, Claude, can you give me a button to turn that stuff off? Hey, presto, we can turn it off. Turn it on again. Off, on, off, on, like Homer Simpson in the garage door. And then I thought it would be quite interesting to see overall what kind of area we're getting in terms of coverage, so that we can look at what kind of coverage we're getting with our tags. So I said, hey, Claude, can you do me a bounding box? Give me a bounding box of the overall coverage. Now, what's really important here is that I didn't write any of this code. I don't really know what this code does, which is terrifying for me as a professional engineer. I vibe coded all of this. I mean, functionally and in terms of feature set, I know what this does because I asked for it. Some of the stuff Claude just did without me asking, like loads of logging, but the simulator it came up with. But I didn't code this. I don't know what the lines of code do because I didn't write them. I just say, give me this extra button, work this stuff out for me, do this, do that. I decided I needed an idea of what the scale of the map was at any resolution. So up here I said to Claude, hey, Claude, give me some kind of line that tells me, what kind of distance we're looking at here. Absolutely amazing. So that's kind of where I've gotten to with this. And it's a little bit like a drug, it's very, very easy to sort of just get carried away and go, oh, I'm just going to put another few features in. I'm just going to do this. I'm just going to do that. So I think, again, this is clearly GenAI is a hugely disruptive, astonishing, powerful set of tooling. There are really significant issues with, things like what we would call hallucination. I don't like that word, but when it just makes things up and it gets it wrong, when it goes up and breaks things, it's kind of like dealing with an idiot savant, you know, and it's knowing how to drive the conversation. And I'm really very much looking forward to doing that. So I hope that was interesting. I thought I would just, show you what we've been up to here. This is part of the INST project, supported by the European Space Agency. And this tooling is what's going to help me to get out into testing in large venues around and about the Northwest as we move towards moving this product, this set of technology into the commercial space. So thanks very much for listening.